So, what we're doing is graphing. They're called parabolas, but we'll say quadratics. Graphing quadratics. And we're going to use specifically what's called vertex form. This is very similar, and I do want to take a look at this. Vertex form. It's very similar to the absolute values that we were doing earlier. Okay, so let's just compare these two. So our parent for these, our parent for absolute value is y equals absolute value x. And our parent for quadratic is y equals x squared. Our transformation or our vertex form which is our graphing form, we want it like this, is y equals our stretch factor times x minus h plus k. For quadratic, it's very similar. Y equals a times x minus h, but now instead of it in absolute value, we square it, plus k. Our vertex then is, for both of these, h comma k. And notice I switched the sign on h, but not the k. Same for the quadratic, h, k. Our axis of symmetry is x equals h. Same thing here, x equals h. Our stretch for both of them is a. Whatever that thing is in front. We've already done a table of values for absolute value x, so I'll just throw one up here really quick, and we can generate that from our calculator fairly easily. Absolute value of negative 2 is 2, negative 1, 1, 0, 1. Yes. Really fast.
I'm sorry.
Yeah.
No, I'll be back to the
I'll send her a message right now.
Thank you.
Yep.
I'm sorry.
No problem. Okay. All right. For this, for our quadratic is xy. So I'm squaring, right? So if I do negative 2 squared, what is negative 2 squared? Actually, let's do negative 3. What's negative 3 squared? 9. Because it's squared, right? That's our parent. Negative 2 squared is 4. Negative 1 squared is 1. Guys, wait. 0 squared is
0.
1 squared is
1.
2 squared is
4.
And finally 3 squared is
9.
9, right? Just continuing my table. So that is my parent.
Wait, you stopped it? Oh, okay.
Okay, so that forms our parent. So let's go ahead and graph our parent. So 0, 0 is the vertex, and then if I go right 1, 1 squared is 1. Do you see that thinking? Just like with absolute value. When we went right 1, we said absolute value 1 is 1, so we went up 1. If I go right 2, 2 squared is 4, so I go up 4. And I don't have room for 3, but I'll go ahead and do what's left 1 is negative 1. What's negative 1 squared? 1, so I go up 1. And if I go left 2, negative 2 squared is 4. So you can use your calculator to generate a table of values if you want. That's fine. And you could graph those. Or you could use that thinking, the same kind of thinking as with absolute value. Notice that it's a U shape. Absolute value was a V shape. Quadratic is a U shape. It's very curved. Okay? We can use this type of thinking to graph any function. Okay? Any of them. And it'll work out just fine. Okay, so let's go ahead and try a transformation. So if I had y equals x plus 4 or x plus 5 squared, what's my vertex?
Negative 5, 0.
Negative 5, 0. What's my stretch?
0.
Not 0, it's a 1. Okay? Okay. So I'm going to start at negative 5. X equals negative 5. And if I go right 1, what's 1 squared? So I go up 1. And if I go right 2, what's 2 squared? 4. Notice that I'm always starting back at my vertex. If I go left 1, that's negative 1. What's negative 1 squared? So I go up 1. And if I go left 2, what's negative 2 squared? So I go up 4. And then that's my quadratic. Here's my vertex, right?
What's that word beside quadratics?
Vertex form.
Vertex.
And then this, right down the middle, is my axis of symmetry, which is x equals negative 5. It's just the x part of that vertex. All right. Let's try another. I won't go on another slide. Let's just do it right here. Let's try y equals 2 x squared minus 5. What's my vertex?
0, negative 5.
0, negative 5. And what's my stretch? I have a stretch this time. 2. So I plot 0, negative 5. It's right here. If you buy into this thinking, graphing these will not be that bad. If I go right 1, what's 1 squared? 1. But I'm not going to go up 1 because I have a stretch factor. So at the end, I multiply by my stretch factor, which is 2. So right 1, 1 squared is 1. But then I multiply my stretch factor, I actually go up 2. If I go right 2, 2 squared is 4. But my stretch factor is 2, so times 2, I'm going to go up 8. And we see this is very, narrow.
Because you multiply it by the stretch factor.
Yep, at the end you multiply by the stretch factor. So that would be a good thing to note over here in our thing. So if we write this down, we had 2x squared minus 5. We had our vertex is 0, negative 5, and we had a stretch of 2. So how we use this is we think, write 1, square it, right, because it's squared. So I get 1, and then times the stretch. And I get 1 times that's 2. So my thinking next would be write 2, I square it, because it's a squared function, right? 2 squared is 4 times my stretch.
Just 2.
So times 2 is 8. So at the end, I multiply by my stretch, whatever it is. And I may want a calculator handy because you could have a stretch that's a fraction, which is actually what we'll do next. And then, of course, if I go left, negative 1 squared is 1, then times my stretch factor, so up 2. And then left, negative 2. So that is 2 squared, negative 2 squared is 4, but then times my stretch, up 8. And that gives me this parabola.
Because you're multiplying.
I'm multiplying by my stretch factor.
Yeah, I understand that. How do you get 8?
Because when I go right, or if I go left 2, that's negative 2, right? It's a squared function, so I square it. 2 squared is 4. But then I multiply by my stretch factor, which is 2, so times 2, 8. So then I go up 8.
It's what you're doing with x to get y.
Yeah, I'm just following these steps. I've already applied my translation by moving left and right. Let's try another. Let's try y equals, let's do negative 1/2 x minus 4 squared plus 1. So in this case, what's my vertex? 4, 1. What's my stretch? Negative 1/2. Okay? So, I start at 4, 1. There it is. And now I pretend like this is my origin. I play pretend. I go right 1. What's 1 squared? Okay, we don't know. 1 squared is 1. 1 squared is 1 times my negative 1/2. So 1 times negative 1/2 is negative 1/2, so I go down 1/2. If I go right 2, what's 2 squared? 2 squared is 4 times negative 1/2 is negative 2. So I go, where do I go? I go down 2. Okay, if I go right 3, I'm squaring it. Do you see why we're squaring it? So 3 squared is 9. Now, I might want my calculator handy. I have times what? I'm going to do 9 times what? Negative 1/2, so negative 0.5. And I get negative 4.5, so where do I go?
Down negative 1.5?
Yeah, down 4.5. So 1, 2, 3, 4, 1/2. Now this is my axis of symmetry, right? So all of these points should mirror. And I connect with a nice curved line. And that's that one in green. erasing the ones that are on the left right here. But I'll leave them on green. Well, that's beautiful, beautiful. Let's do one in black.
No, it's 3 squared, which is 9, and 9 times negative half.
All right, so this one. We'll do lots of them so that after the notes, so you get practice on figuring out how to do it. What is our vertex? That'll be the first thing.
2, 4. Negative 2, 4.
Negative 2, 4. Good. And what is our stretch?
Negative 1/3.
Yeah. So A is negative 1/3. So this is where we're really going to want that calculator handy. And we're going to go ahead and do it with decimals because it'll just be easier to estimate where we should put our dot. So we're going to start at negative 2, 4. So there's our starting point. And now I do everything with respect to this. I pretend that this is my origin. And then if I go right 1, I'm squaring it, right? Squared. So 1 squared is 1. Then times negative 1/3. And on my calculator will pop out negative 0.333333. So I'm going to go down 1/3 of the way. Okay, if I go right 2, 2 squared is 4, right? Times negative 1/3. And I have my calculator handy and I get it as a decimal and it pops out negative 1.333333. So I'm going to go down 1 and 1/3 more. Negative 1 and 1/3. If I go right 3, 3 squared is 9 times negative 1/3 is negative 3, so I go down 3. And these mirror over here. Notice that when my stretch is a fraction, it like widens the graph. So you could think of that as a horizontal stretch, a vertical compression. If it's a number like it was 2, it narrowed, so that's a horizontal swoosh, horizontal compression, but that'd be a vertical stretch. Okay? So without graphing, we're going to think of some answers to a couple questions. Let's say I have we aren't going to graph them. I want us to do, I'll put it down here, get the vertex. I want us to get the axis of symmetry. and I want us to get the stretch. Now I'll do the top two with you, and then try the remaining ones on your own in your notes, see how you do. So what's our vertex for this first one?
2, 0.
2, 0. And what is our axis of symmetry? X equals 2 is the x part. And our stretch is
1.
1. If it's not written, it's a 1.
Yeah, how is...
Because there'd be a 1 here. If there were a 0 here, then all of this would be 0.
Yeah, x equals 2.
So the axis of symmetry is the x part of the vertex. All right, what's our vertex for the next one?
3.2, 4.
3.2, comma 4. And what's our axis of symmetry? 3.2. And what's our stretch? 0.1. So that's why you want a calculator handy, so that you can, estimate those better. And there's no reason that you have to use right 1, right 2, right 3. You could go right 4 if it's convenient to do that, and then just make it connect. So we'll do one if we have time that's like that. Go ahead and do 3 through 6 while I go deliver messages. All right, wasn't that fun? All right, so what's our vertex for number 3? I'll just put it up here, -3, 0. Our axis of symmetry then is x equals -3, and our stretch, 1. You could, instead of writing stretch, you could say a equals 1, because that's just the universal stretch factor. Here, our vertex is -1, -1. X equals -1 is our axis, and a is 0.35. Again, this is why you have a calculator handy to graph these, so you can estimate those. Just kind of quickly multiply, square and multiply.
Once you reverse that one, you got -5, 0, do you reverse it to the axis
Nope.
of symmetry?
Nope, because the axis of symmetry goes right through the vertex. Number 5, -5, 0. And then our axis is x equals -5, and our stretch is 1. And the last one,
It just asks you that.
yeah, I know. Yeah.
So you
Did it?
do
No, well, you keep this, whatever it is. That's what I meant. Okay, I misunderstood your question,
So
sorry.
you keep the -5 for the vertex, but do you make the 5 negative for the axis?
It's whatever the x is for the vertex, that's the axis of symmetry. These are the same. Sorry, I didn't understand what you were asking. Okay, the last one, our vertex is 120, 50. Our vertex, or our axis of symmetry then is x equals 120, and a, our stretch is -4. All right, I think we're good. Nothing else? No. All right. That's it for notes.